The WHO and the United Nations has, as part of the Millennium Development Goals, defined what is an acceptable, what they call improved drinking water source, and what is an unimproved drinking water source. And of course, the goal is that every drinking water should be improved. So if we start from the bottom, the unimproved drinking water is an unprotected dug well, the one which is not having a lining, unprotected spring where the water is just running out without having the spring box, cart with a small tank or drum. That is often you see someone selling water from a small truck with a horse in front or something. Tanker truck. This is something that is all not very commonly in developing countries as such. But if there's an emergency situation, a tanker would drive out and sell water. It's also not improved. And then all kinds of surface water, like rivers, dams, lakes, ponds, stream, canal, irrigation channel. As I said, some of them might, if improved, be good enough, but mostly surface water is not good because of the quality. And then bottled water is also not considered unimproved. I think not because bottled water is unclean, just because it costs money, so people would not use it. So these are the unimproved water sources. The good ones, the improved water sources, is the pipe water into a dwelling, the taps to the yard or to the plot, public tap or standpipe, tube well, borehole, or protected duct well, protected spring, and rainwater collection. So these are considered good and bad. You can find situations where I would say like a dam, a protected dam would be good enough. Same times, I would also say rainwater collection is good in itself, but it's not. If it doesn't cover the whole year, it is not. I mean, the situation is not good enough. So there are some exceptions you might say. However, if you treat water, then you could maybe use some of these water sources as well. So an unimproved drinking water source becomes an improved drinking water source. And that's what I'm going to talk about now, the different ways that you can treat water. We have some water quality problems that are health related. The microbiological, we've talked a lot about this in this course. All the bacteria, the viruses, all the disease-forming microbes is a problem for the health. Then there's some natural chemical ones. Fluoride, arsenic is fluoride is giving limited movements because it kind of create more bone into the elbows, into the knees, and it destroys the teeth. Arsenic is making you can give you cancer because it destroys the liver. So sometimes these things are found naturally in the water, not as a pollution, but not a human pollution, but naturally, and that's a problem. And then we have some man-made things. If we have too much nitrate, heavy metal, pesticides, even chlorine that is used for treating the water. Some things, our pollution can also create problems for the drinking water. But we also have some water quality problems that are not disease-forming, but we call them organoleptic. That means the taste, the odor, the appearance looks bad, it tastes bad. And there may be some taste from the hardness, from the salinity, if there's too much salt in it. Iron, manganese can give a bad taste. So it means that you won't drink this water. You don't like it because it looks bad, it tastes bad. Iron containing water is very ugly also. So, but the problem is as big as this one, because if you don't want to drink this, then you go back to the other one, the other source that may be contaminated with microbiological things. So it is, even though it sounds like organoleptic is not such a big problem, it's just a taste, but it means that people are not drinking it. And then there is some technical problems here with some aggressive carbon dioxide. The pH, the alkalinity may be problematic. Hardness, iron, some things that may clog your pipes with time. You all know about hardness. We have to clean our taps once in a while here in Denmark, for example. We have a lot of hardness in the water. So there's some technical problems with these. If we look at where do we find these problems? If we look at springs, sometimes we have fluoride in the springs, but that is the biggest problem normally we see there. In the groundwater, we sometimes find fluoride, we sometimes find iron, arsenic, manganese, dissolved solids, salinity, that is the same. Calcium we can find in some groundwater. In surface water, the problem is completely different. That is bacteria, it is suspended solids, particles, nitrate, BOD is organic matter. And then the brain is typically not so much of a problem. But the alkalinity may be a problem, as we said, the problem with the soap. BOD may be a problem if the roof is dirty. You can also get some organic things into that. So it's quite different problems you find, especially between surface water and groundwater. And they have to be treated in different ways. So when are we going to treat? Just to start, just to frame this whole thing, it's not always you treat it, and there are some reasons that you don't do it as the first thing here. You should start looking for a feasible source. If there's another source that you don't need to treat, you would go for that, investigate that first. Treatment is usually difficult to maintain. Somebody has to treat it, and we have to control that it's treated well, and it is difficult to do. Sometimes it also costs money. Some can be very cheap, so it's not a big problem, but it costs some money every day, every month. You have to pay something, and requires motivation and training for the people who have to do it if they're in the households. Or if it's a common system where someone is employed to treat it. It's not everything we can treat. For example, salinity is not on the list here. Those things we can treat is bacteria, silt, particles, iron, manganese, fluoride, arsenic. These are the things that we can treat. But salinity we can also treat, but not in practice. I mean, salinity is something you can treat with a big reverse osmosis machine, but it's something that you don't install in a village because it's expensive and it requires very high skilled labor.